हाँ सर, check. Yeah, ma'am, please mute, ma'am. Yeah, sir. Yeah, sir. It's visible. Good morning, everyone. The session will be starting in 2 minutes. Good morning, everyone. Myself, Chaitanya, Assistant Professor, Department of CSE, Geetham School of Technology. I would like to take this opportunity to welcome Mr. Speaker, Avinash Sir, and participants and all the organizing committee for a webinar on application security. And the session is going to start in a minute. Before that, I would like to inform you all that the last 10 minutes will be a questionnaires. So if you have any questions, you can drop your questions in a comment box in a YouTube link so that all your queries will be answered by a speaker. Over to you, Usha ma'am. ठीक है? One second, one second. Yeah, this Avinash sir, your voice is not coming in YouTube, it seems. Now just cross check, sir. For me, it is audible. I think you have to check, sir. For me, it is audible. No, it is not. Yeah, I have connected. Desktop audio is not moving. Huh. Output, what I have to select? Hello? One second. Uh, s- I'm not getting here desktop audio, sir. Yeah, I have gone, sir. One second, sir. Audio, okay. Desktop audio is default only, sir. Audio, yeah. Just check, sir,
Now
enough. One
press
second,
OK,
sir.
ma'am.
Yeah, I have done. Audio,
Yeah.
okay. Desktop audio is default only, sir.
Okay. So maybe now it should be
Audio,
fine.
yeah. Now you can hear.
Is it fine?
Yeah.
Your voice is not coming, sir.
Just check, sir, enough.
Yeah, it's coming now. Good.
Press OK, ma'am. It's coming.
Yeah,
Right,
Yeah,
right,
it's
right,
coming,
right.
sir. You can carry.
audio.
Very good, very good.
Chaitanya, madam, you just tell them sorry for the disturbance.
Okay. So maybe now it should be
Audio.
fine.
Yeah, now you can hear.
Right, right, right. So once again, I'll be sharing my screen now. So welcome back. I hope all of you can see my presentation and hear me as well. Right. So what I was saying is, first of all, thanks to Professor Usha Madam for introducing me, and I would also like to thank Geetam University and management for giving me this opportunity to bring these insights on application security. And I'm so glad to see so many participants in this webinar session. And I hope all of you are staying healthy and safe. And with that positive note, let us begin the session. And for bandwidth restriction, I will have to turn off my audio. So let us begin the session on application security. I will start with the contents. So I will be talking about introduction to current security trends, also importance of application security, recent trends among security threats, categories of applications, mobile application security, and I will be discussing about security techniques for developers as well as safety practices which can be used by end users. So first of all, what I want is start by talking a little bit about the importance of application security. But before we do that, here is a question for you. So what we are gonna do is take a minute. I want all of you on your smartphone or on your laptop or on your tablet, go to this website called www.menti.com. Take this code 9768309, right? So go there, go to this site, and once you enter this code, you will see a question in front of you. The question is this: name the application you uses the most. It could be in your mobile or it could be from your web application. So I hope all of you are in this website www.menti.com and you have entered the code 9768309. The question is name the application you uses the most. And generally we do them in person as it is easy for asking these kind of question and answers. But when you're doing a session like this, a virtual session, it is much more difficult. So I just found this a cool way of doing this. So I hope you are at menti.com. So also I need to make sure you are seeing my screen, right? So already I'm starting to get answers already, very nice. So let me show you the answers here. This is what you have, you people are putting the results. I can see WhatsApp, Instagram, Zoom, uh, and as you can see, you can observe some kind of a pattern becoming here. Already I am having 9 results already, right? So with this, I can conclude most of the people use applications such as YouTube, Instagram, and WhatsApp the most. Some of you have told like music, WPS, Google Meet, Udemy, music, Telegram, right? So these are the a cool way of getting the results from your end. Now, that's nice. Thank you. Now let me switch back to the presentation. Thank you for your results, everyone. Right. So if you have followed security in the past, even if you have read about hacking or cybersecurity or information security, you know there are a lot of different aspects to it. And for the most people, when we think about cybersecurity, they think about security against attacks on networks or about phishing attacks or about people doing frauds, etc. But over the last about 8 to 10 years, one of the fastest growing areas of security has been application security. And one of the reasons for that is because there is a software everywhere. Cut to 2020 in today's age. Yes, we still have web applications, we still have mobile applications, and you know, a lot of us use mobile applications today, but there is a software in our refrigerator, in our cars. There is a software in our speakers. If you use Google Home, Amazon Echo, etc. So right now, what has happened? Software has expanded from used to running in certain limited applications to basically being part of every object in the world. That's one reason why software has expanded everywhere. And therefore, because software running in applications, application security has also expanded, because as long as there are more software vulnerabilities, there will be more security bugs. There will be more hackers wanting to hack applications. So that's one of the reasons why application security is very important, and to study or know about application security is equally important. The second reason is because something called cloud, which you all might have heard of. Now, traditionally, we deployed applications to what we call data centers, right? So there would be a large air-conditioned rooms with a lot of server racks connected via a lot of cables, which would host many operating systems, many computers, many databases, etc. And you would store and run application through those servers. And these servers were also managed by you. So if you wanted more server capacity, you would actually buy a box, or let's say buy a hardware from the store, go and fix it there, connect the server, and then deploy the application, right? This was the story many years ago. Today, because of the cloud, that has changed. If you want a new server, all you have to do is by a mouse click, either you just go to Amazon Web Service, right? Microsoft Azure or Google Cloud, and you can provision a server without buying any hardware. In fact, one of the common ways of using the cloud is actually through code itself. When I say code, it's nothing but the software that runs in your application. So now we can write software to kind of creating a hardware required for your application. You would have noticed or heard about how cloud applications work. There's a provision like buying the storage. You can buy the storage from the software or application itself. So even a lot of infrastructure has become software defined. So because of this, right, from your connected cars to your connected microwaves to your connected speakers, all the way to infrastructure also being dependent on software. And because of all these, the largest attack surface for hackers is now your applications or the software that you write. And therefore, the importance of application security has also gone up over the last many years. This is the reason why if any of you want to be or want to kind of have a career in cybersecurity or thinking about cybersecurity as the option to study further or work on, then the core area of interest should be applications. So application security is one of the core aspects of cybersecurity. It is not getting the attention it deserves. Many developers tend to focus on aesthetics, functionality, and performance of the applications. And this inevitably means they give less priority to security of the application. Talking about application security, I will start by defining these terms: application and security. So what is application security? Simply put, application security is the general practice of minimizing the vulnerabilities to your applications, making it immune to a range of cyber threats. But the real question is, why should we care about application security? I just told you the importance of application security, right? Because software is everywhere. We use it in all our daily life. So let's start with looking at the first word, which is application, right? So all of the conversation that take place today, that we are involved in today, almost everything is done using one form of application or another. Most of you, if not all of you, have some sort of end devices. Like I am using a laptop. From your end, it could be a smartphone or tablet or a PC that you are attending this particular session on, and you are using some sort of application to do that. For example, YouTube. In fact, even as humans, when we are talking to each other, most of the application conversations are replaced from actual physical conversation to the conversation that take place over an application. and that is due to the pandemic, right? For example, this meeting is via Zoom application. Other examples such as WhatsApp, Facebook, etc. So applications have become part of our life now. In fact, not only part, it has become a part of a vocabulary, a verb, an action that we do. As for the famous advertisement goes, Paytm karo, just Paytm the money over to me. That's how people say these days. So applications are prevalent. What the applications do themselves, they may give you payment services, banking services. There may be social media kind of applications with which you can communicate with people. I see a lot of you are from university, college students, maybe researchers, maybe some of you are professionals. And if you're working on some sort of project or developing something new, innovating and creating something new, you may be thinking about creating an application for people or as an interface for the people to talk with. So application development and applications are everywhere, right? So it is one of the top jobs from professional perspective as well. And that's the reason why everyone is after that. And guess what? Attackers are where the people are. So we will come to that in a bit. Let's talk about the second term, security. Now, just like app development is the one of the most important and top paying jobs, security engineers themselves are among the highest paid engineers in the world. Important distinction is that security is not just the business of security engineers or developers itself. It's everyone's business. Like I was mentioning earlier, why should we really care about application security? Why do we need it? All of us are there, right? In the application, we are using it. And the bad people, the attackers, hackers are also in the business of making money. And how do they do that? They go and attack where the people are. So where are the people today? People are on some sort of applications or another on their smartphone, on their computers, on their laptops or whatever. As the usage of application is increasing, the attackers are also attacking those applications specifically. So if you are a developer or if you are just a person that uses an application, all of us uses an application, right? You just mentioned that results. Thinking about securing it is extremely critical because we are putting our data in, we are feeding our data in that applications. If not, we are putting a lot of components at risk. So this graph basically shows you an example of how over time most of the attacks most of the attacks and this is specifically talking about DOS attack, denial of service attacks, how they have increased again application level protocol 64% and network is 51%, right? That's VoIP, voice over internet protocol, SMTP, HTTP, as compared to the network level protocols such as TCP, UDP. So applications are where attackers are specifically moving. Talking about what are those reasons why attackers are going after the applications. I actually heard a bunch of questions earlier. In spite of having so many security solutions to protect the network like firewall, antivirus, intrusion detection system, intrusion prevention system, we why are we still seeing malware, viruses, ransomwares, and all those things almost on a daily basis? Why is it that we are not able to protect ourselves 100% of the time? The reason is because the applications that are being developed and deployed, you can see here that more than 1 out of 3, more than 34% of the applications having some kind of vulnerabilities or I should say, loopholes in them that are critical or high. What that means, attackers can easily attack one of three applications using some form of a vulnerability. And most of these are due to the poor design of the application. So this is a breach report by Verizon. Verizon is just like a telecom provider in United States, just like what we have as Geo and Airtel in India. So apart from providing telecom services, Verizon also releases some kind of a data breach annual report. And in 2019, they specified like most of the breaches incidents happen with respect to the web applications, right? So here's a question for you once again before moving to the next slide. So I hope you are seeing my slides as well, right? This was the answer given for the previous question. So I request all of you to once again go to this site called menti.com, write down the same code 9768309. And the question is this: what are, in your opinion, different categories of applications? So I hope all of you are there in this menti.com, right? Also, I would like to say the weakest link. So we say at that point where you are giving the answers, let me just talk about the weakest link. So let's see the answers if we have received. Yes. So you people are now answering. What you all have to do is go to menti.com and use the code 9768309 and input your answers. So come on, people, let's see some response coming in. So we'll take a minute here. Right. The weakest link in all these chains you might think is applications itself, but it is generally the human that is involved in the decision making factor, which is why applications is insecure. It is either the person who has developed that applications or the person that is using the application. I will be taking you in the next 20 minutes. I will be taking you through some key concepts specifically about application security, how we as a users can be secure in the various applications that we are using. So, right. When we do this session, I found this is just a cool way of doing this. Let's see some more answers coming in. I hope you can see, I hope all of you are seeing the result on my screen as well. Great, I can see a lot of people responding, and you can actually observe again a pattern developing already. Most you are answering about education, social media, mobile. You have also mentioned mobile, gaming app. Some of you have also mentioned gaming app, educational apps, or desktop applications. Very good. Great. Just great answers. Right. So, okay, yeah. So I agree there are different ways in which you can categorize applications, and what the answers you are giving are those as examples. So you can see education, entertainment, social media, mobile, web applications. So for the purpose of this presentation though, we are going to look at two main categories of applications. So let me just switch back to the slides presentation. Thank you for interaction with that. Right. So as I was saying, for the purpose of this presentation, we are going to look at two main categories of application and focus on only one of them. There are web applications, right? And there are other kind of server applications. I'm just going to call them as server based applications. It could be web, it could be email, it could be VoIP, or all those kinds of server based applications. The second category, which is more prevalent these days as everyone is having a smartphone all the time, is mobile applications. So we are going to stick with or talk about mobile applications specifically and the security concepts related to them. Okay, so what are the those three key concepts we all must be aware of when it comes to mobile application security? Here they are in order. The first one is authentication. The word is quite self explanatory. It basically means a mechanism through which an entity, a person, or a process, or a thing can prove its identity to the authority. So that is authentication. An example is going to the airport, and before you can enter the premises, you have to give some sort of a identity to prove that you are the person that you see on the ticket. That is authentication basically. A very simple concept. Another example of that is you using your user ID and password to access a particular website. In this case, for menti.com, you entered a passcode and you access that website. Second category of the second key concept is authorization. It is slightly different from authentication. It talks about privilege levels, what kind of clearances or what kind of privilege level an entity has. All of these concepts can be applied to either a human or a general thing or a process. The last key concept is data security. In fact, I was actually reading the other day about zero trust security. Zero trust security is a concept that says organizations should not automatically trust anything inside or outside its perimeters, and they must verify anything and everything that is trying to connect to its system before it can grant access. So few pillars of that consolidates zero trust security are users, devices, networks, application, and data security. This is what attackers are after these days. And through this data, they are looking to make money. So let's take a look at each of this concept in detail and explain them a little bit more. I'm going to talk, I'm going to start with the data security first. There are three keywords that we need everyone to know when it comes to data security. Those three keywords form something called as a data security triad, which includes again three key principles known as confidentiality, integrity, and availability to ensure any form of security system. Data security triad, also called as CIA triad, if you just take the first alphabets of C, confidentiality, integrity, and availability. Now, why it is important, I would just go through each of them. Confidentiality of data is making sure that only the intended, the legitimate users, or only the people with the right level of privilege have access to the data, and it is hidden from others. It is not disclosed. For it's like a privacy. It's not disclosed to the people unless they have the right level of clearances. Integrity of data is making sure that if I say hello, you should also hear at the receiving at as hello. You should not hear goodbye, or you should not hear hello in a different language. It is making sure the data is not tampered or modified. It is not transformed, or you can say that it is not garbled, or someone in the middle has not tampered with it while it was in transmission. And availability is making sure that the data is available at all the times to the people that need to use it. See, we have had multiple instances where recently where there have been many outages of different kind of services. If you had tried booking railway tickets a few months back when the pandemic started and lockdown was imposed, when the government first opened railway services, you would have noticed IRCTC website was actually down for most of the people, because I tried it and I know. So availability is making sure that the data or the services of an applications are available to the users when they need. Because what is the meaning of the uh, something, let's say some information, if it is not available to you, right? So these principles of the triad CIA are considered as the heart of information security. And if you are thinking about designing a secured system, think of these words: confidentiality, integrity, and availability. And if you can keep these three concepts in mind when you're designing a secured system, you are almost guaranteed to be all the way there to design a fully end-to-end secured system. So the next key concept is authentication, right? When you talk about authentication, people generally talk about multi-factor authentication, basically more than one factor of authentication. It's a concept of proving that you are who you are claiming to be, to prove your identity. But just showing a card or entering a password is not enough these days. Most common way of doing authentication even today is through simple passwords. If you're logging into some sort of applications or a server, it generally asks for a username and a password. But people have realized that doing just one factor of authentication, which is just a password, is no longer enough. There are actually multiple factors of authentication, and that one has to keep in mind. The first factor of authentication is something you know. For example, that I just gave a password as an example is something that you know. If you enter a password, then you're proving that you know the password. But that doesn't mean that you are the correct person. If your password is stolen, or if you have mistakenly given your password to someone else, or someone else guesses your password, they still get through the application. They are still able to log in successfully. And if you just use one factor of authentication, it is simply not enough. So how do you make it more difficult? So you add another factor of authentication, and that could be something you have. For those of you having a banking accounts and you try login into your online accounts, or when you do some banking transactions, after you enter your password, you generally get a one-time password, right? Sent to your mobile number. That is an example of second factor authentication, because only you have your smartphone. Most of the times, unless your phone is stolen, you have your mobile. So that means you are authenticating through your mobile and proving that your phone is with you. So something you have proven through your second factor authentication is something like a one-time password. But again, like I said, that may not be necessarily enough. Phones can be stolen. Google the term pin swapping attack. You will see a lot of articles on how people have lost money because of pin swapping. So then you might need additional factors of authentication. And there are at least three more. The third one is something you are. And something you are basically doing it through characteristic of yourself. Generally, something you are is through some sort of a biometric authentication. It can be a fingerprint, it may be a iris retina scanner, maybe just through facial recognition. If you have smartphones that supports facial recognition, you are using them. If you have fingerprints sensor in your smartphone, you are using that as a third factor of authentication. Even Aadhaar uses that as a mechanism of authentication before you provide your KYC services to someone. You are requested to give your fingerprints scan to prove that you are that person claiming to be, right? Just a second. Okay. So that is something. There are two more lesser known but quite important factors of authentication. Those are called somewhere you are or something you do. Somewhere you are is important mainly when you have to prove that some location where you belong. There may be services that you are only allowed to access if you are within a certain location or premises, right? Especially in present days, you think about how COVID is growing. Most of us working from home, you have to prove that you are at the right location. Something you do is actually something new that I have learned very recently. And if you are a Windows 10 operating system user, there is a novel way in which you can unlock your Windows 10 machine through gestures. Gestures means you do some sort of an action on the screen and prove that you are that person. It is a random action you have decided and registered in the machine at a particular point of time, and no one else can actually copy you. So through that you are the person, through that you can prove that you are the person who are claiming to be. So those were the different factor of authentication when it comes to authenticating the uh, user. But how would you authenticate an application, right? Some of you may ask questions like about how do I verify source of a file? How do I make sure a file is not malicious or it's not bad file, right? If I'm downloading a file, how do I make sure it is genuine source or a correct from a correct person? So application developers do something called as application signing or code signing. So you have original piece of code. It could be a, let's say it could be a file, could be a mobile application, or could be a desktop applications, anything that it may be. The person that owns or developed that piece of code is generally going to use some sort of a key. In this case, a private key to sign a digital signature onto the code. Think of signature you put on your paper. That is a web signature, right? But now you have concept of digital signatures. So with public key infrastructure, you have asymmetric encryption. You have two types of keys, right? Private key that goes along with a private public key. Private key is only with the person that owns that particular key. The key is never disclosed or distributed. And that key is what developer uses in order to create a digital signature, and then they attach it to the application. So now they're saying that, hey, that this piece of code is signed using my private key. So you can now trust the source of this applications or this code. And as a user, when you get this piece of code onto your phone or onto your laptop, you actually decrypt the signature using the public key of the developer. Remember, the private key and the public key are in pairs, they go or in a combination. So that means if something was signed using a private key, you can only get decrypted using the public key that goes along with it. So encryption is basically the reverse, right? You encrypt the public key and you send it to the developer. So only a developer who has the private key can decrypt it. That is encryption. And when it comes to finding that, let's say, okay, so you had confidentiality, integrity, and availability, right? Through the private key, you are making sure integrity is maintained. No one can tamper with the application that you are creating, the code you are or creating, or the code that you have developed. One second, I'm getting some message here. Fine, right. So as the end users, you can actually verify the code you are developing is not modified and still the same authentic one, and you had that the one you have originally developed, right? So let us talk about second key concept, authorization in little bit detail. I will just go through it very in a few minutes. I'll not take much time in this. So not going to spend a lot of time. Authorization mainly talking about level of clearances that you have in order to enter certain location or applications. Earlier, I took example of bank. It is very rare that people physically go to bank these days. But if you are one of those who go to bank, right, you would have know these different. There are different areas in the bank. Same way, your applications work how a bank operates. There is a general user area open for everyone. Privileged user areas like for special customer, like employee workplace where a customer cannot enter, but only the employees can enter. And we have safe deposits, right? So we have a vault, which is the most secure, right? So basically, when it comes to applications, there are multiple levels of access or clearances that an application has, and you must think about it. You as a user generally are in the outermost ring where the all the applications are running. So in your phone or in your tablet or on your laptop, the applications are running in the most insecure area of operating system. And to get every subsequent area, you have to make sure that you have the right level of clearance. In fact, most user applications don't have that level of clearance, right? So this is where, as an application developer, you have to make sure that your application only requests for level of access that it needs. If you don't need storage, don't ask for it. If you don't need access to camera, don't ask for it, right? I'm going to actually talk about that towards the end, but this is some of the security techniques you as a developer can use. So nearing the end, let's talk about what are the different ways in which you can actually secure yourself as a user or as a developer. The concept of sandboxing. What is a sandbox? I mean, in our community, we don't really use sandboxes a lot, but it makes sure that a particular process runs in a self-contained environment within itself, and each application has its own sandbox, so they don't directly interact with each other. They all run with their own little box. So a very common word that we are all hearing from the past 6 or 7 months is social distancing, and the second most common word is quarantine, right? People that we think are affected with COVID are going through mandatory period of 2 or 3 weeks of quarantine, be it at home or quarantine facility. Sandboxing is similar to that. As an application, I don't know if it is good or bad, but what I can do is make sure that whatever you do as an application, do it in a self-contained space. So you don't spread whatever badness you might carry to the others. That is the concept of sandboxing, right? In fact, for the past 10 years, Chrome as a browser has always been running as sandbox process on your desktop or on your phone. If you're an Android user, every single application in your Android phone always runs in a sandboxed environment of its own. So that one application cannot talk to another application unless you explicitly grant permission to do so. You would have noticed if you get a link, you will click on that link and you will prompt an action, open this file using this app or that app, or choose an app to open this particular file. Same way, you are explicitly telling the application to interact with some other application. So talking about next key technique is going back to the data security triad: CIA, confidentiality, integrity, and availability. This is talking about the first two, confidentiality and integrity. How do you maintain those two? You maintain those two by making sure you are encrypting your data at every single point of time. Data can be in the three states, just like any matter can be in solid, liquid, and gas. Similar to that, data can live in three different states. It could be at the rest, when you store it in some sort of databases or something like a pen drive. Second is data in could be in motion, like when it is being exchanged between two entities, right? I will send an email to you, so that is a file transfer session that is in motion. Data is in motion. And lastly, data should be in the use when I'm actually reading or doing something with the data. At all these three states, data must be always encrypted. And remember, the encryption happens with the public key, and same data can be only decrypted by the person that has the private key. Accountability is maintained through signing digital signature. Blockchain works on similar concept. You all must have heard about that buzzword blockchain, maybe not in detail, but how it works on the historical concept of digital signatures. When digital signatures are created using the private key, anyone who receives that message can always verify the source of that message using the public key. So this was the second key concept, which talks about confidentiality and integrity of data. So nearing the end, or taking a step further, if not all, most of us used VPNs, virtual private networks, talking about secure communication, right? We all have heard about VPNs, right? We all have used VPNs, if not all, most of us, especially for good or bad purposes. I know there are people out there who use VPN in order to gain access to the data that they should not do, which is absolutely wrong. I'm not encouraging that behavior, but some people do that. But at the same time, it can be for the good services also. Right now, when IT professionals are working from home, them as an employee using VPNs to connect back to organization's environment or company's servers, that actually encrypts all your traffic just going out of your system. So if you have a phone or a laptop, it encrypts all of the traffic from your device going to a particular destination. Per app VPN is actually taking it down a level below. What it does, it creates a separate transmission channel which is encrypted for each application. So if you have an email application, it has its own communication channel to the email server. If you have a messenger application, it has its own secured communication channel to the messenger server. Same way for banking applications and so on. So at each level, you are encrypting it, but at the same time, you are isolating it. So this brings us to the end as a user, what you can do. Now imagine this is your smartphone and you just open a new bank account with the bank. Let's just call it a My Bank for the namesake. I don't know if there is a bank that exists by that name. Let's just call the bank as My Bank. So as a user, you must say, as a user, you say, okay, you have a mobile banking facility. So you're going to download that application that is provided by the bank. First, when you first launch that application, the bank starts asking you for the permissions. It might ask you like, it might ask for access to your messages, your SMS messages on your phone. So you think maybe it is for your OTP or notifications, but then you see it is also needs access to your storage on your phone in order to store some data. That is interesting. You move on. You see the third one, it needs access to gallery to look at the photos and video. So why does a banking application needs that? You already starting to have doubts. Then you see it's also asking for permission to access your camera. It has happened to me personally. So in fact, a banking, what I did, to my surprise, I default denied all permissions to new applications, and I actually see what happens. And to my surprise, though my bank application was asking for all this permission, even despite denying each and every permission, the bank application worked just fine. So whoever developed that application for some reason put those permission in there, but not actually using them. That is a bad design in nature, right? So when you are designing a mobile application, think about what sort of data you need, or what sort of access permission you need. If you don't need camera access, do not ask for it. So that's the end of the session. And I in this presentation I introduced to a lot of key concepts. Like I said, we don't have enough time to go into details of each one of those, but here are some references you can go back to. You can read more about it and take these terms. Idea is that we have introduced you to it, and you take it a step further and become a secured netizen, not just a secured citizen going forward. So with that, I will hand it over to the coordinators. If there are any questions, you can approach. Thank you.
Yeah, thank you, Avinash, for your informative and valuable webinar on application security. Participants, if you have any queries, you can place it in the comments and it will be addressed. And you will be receiving a participation form link in your mail. Kindly fill the participation form for providing you your e-certificate. So do check your mail also. I would like to invite Nandini ma'am for delivering vote of thanks. Nandini ma'am, over to Nandini ma'am. Ma'am, unmute yourself.
Yeah, thank you, ma'am. I, Nandini S., would like to take this opportunity to provide on record our hearty thanks to Geetham School of Technology, Bengaluru campus for the support and guidance in conducting the event. I extend my heartfelt gratitude to Professor D.S. Rao, Pro VC, Bengaluru, and Professor Dinesh Seth, Director, Geetham School of Technology, for their support. I also extend my thanks to Professor Brahmananda SH HOD, Department of CSC, to his enormous cooperation in the organization of this event. A big thank you to Mr. Avinash for his support to the ideas he shared with us for the security of applications. Further, we are very grateful to Mr. Avinash for demonstrating his ideas. Well, ladies and gentlemen, an event like this cannot happen overnight. We have been fortunate enough to the back end by the team of our motivated and dedicated colleagues of Geetham School of Technology, Dr. Gina Jacob, Dr. Usha Ruby, Mr. Etish, Mrs. Chaitanya, and Mr. Sahana for their support in successful conduction of this event. Ladies and gentlemen, once again, I want to state that we all are most grateful to all the participants for joining this webinar and made it successful. We thank you for being with us in this Sunday. Stay safe and stay healthy. Thank you very much.
Thank you, ma'am, for your support also. Thank you all. And a series of webinars are waiting for you in the near future. I hope we can connect again. Stay safe, stay healthy, and have a good day. Do we have any queries? in comment. Unmute, the Chaitanya, unmute yourself. Yes, thank you all.
Thank you, everyone.
Thank you all.